Hi everybody, and welcome to a short introduction to our paper, Learning to Break Deep Perceptual Hashing, the use case NeuralHash. Last summer, Apple announced its NeuralHash system for the detection of illegal material on user devices. NeuralHash is designed to detect child sexual abusive material, or CSAM in short, directly on the user devices before the files are encrypted and uploaded to the iCloud service. At its core, NeuralHash is based on deep perceptual hashing to compute fingerprints, the so-called hash values. The computed hashes are then checked against the database with hashes from known illegal material. If a larger number of matches with the database is detected, the local authorities are informed. When Apple promised to ensure user privacy and security, a lot of criticism arose. In the end, Apple cancelled its plans for NeuralHash and postponed the deployment indefinitely. However, client-side scanning is still discussed as a solution for crime detection, for example, very recently in the European Union. In our work, we investigated the risks of client-side scanning from a technical machine learning perspective, in which NeuralHash acts as a real-life example. In our research, we investigated two adversarial settings, namely hash collision attacks and detection evasion attacks. In both settings, we have an adversary that can manipulate the content of a set of images. The adversary then sends these manipulated images to a target device on which NeuralHash is running. For the setting of hash collisions, the goal of the attack is to create an image that is then assigned a hash value matching one from the existing hash database. For the evasion attack, the image is manipulated in a way that its hash value differs from the hash of the clean image to avoid detection by the system. Here, we show one result from our collision attacks, performed on an image from a Black Lives Matter protest. As you can see, both images on the left are visually hard to distinguish. However, the hash values produced by NeuralHash for the images are completely different. Moreover, the hash value of the manipulated image matches the one from the unrelated dog image. This demonstrates the real applicability of such collision attacks, which allow an adversary to frame innocent people or even monitor them. In summary, our research shows that current systems like NeuralHash are likely not robust against various attacks. Already rotating an image by as little as a single degree changes 5% of the hash bits on average. So illegal material, such as CSAM, could easily be hidden with little effort. Even more, hash collision attacks allow an adversary to frame or monitor innocent people, and therefore the whole system could be abused for malicious purposes. This brings us to the conclusion that current client-side scanning systems based on deep perceptual hashing are not ready for deployment. We provide more details on NeuralHash, our attacks, and the results and implications in our paper in the long presentation. We are happy to answer your questions and are also interested in your view on this topic.